The next science skill we're going to be looking at is graphing. And we're going to talk a little bit about what kind of graphs are out there, how to make a graph, and which type of graph to choose when graphing your data. Go ahead and open to the next blank page. Please label the page Graphing Notes. Be sure to include the date that you are taking the notes. You're going to want to divide your paper into 2 columns here. Include a narrower column on the left for big ideas and a wider column on the right for supporting details. Pause the video now to do that. So first I want to just take a brief look at why we graph. So we collect this data, we put it in a beautiful data table, excuse me, and there it is. Why do we bother taking the next step and graphing the data? Well, it's actually really important because graphing is essentially creating a picture of your data. And I don't know about you, but I seem to understand pictures better than I do words or numbers. So if someone drew a picture of something or showed me a diagram, I'm like, oh yeah, that makes way more sense. So graphing essentially takes your data from a jumbled up bunch of numbers and puts it into a picture for people to look at, which makes it very easy to share it with others when you want to, and scientists like to share their data with others. Another thing is that it's much easier to pull out any trends or patterns when looking at a picture of data instead of the numbers, which in turn makes it way easier to analyze the data, which is what we want to do. So let's look at some types of graphs. First type of graph is a line graph, and I'm going to pull this up here just a little bit because it is off the screen. So a line graph is used when you want to show a trend. So you want to show something happening, direct correlation, right? So for example, if I'm showing growth over time, it's a trend happening, the data is connected. Here I have pressure as I change a temperature. So I'm showing the trend in what happens to the pressure as I change the temperature. Very important that you use a line graph whenever you're showing a trend. Next one is everybody's favorite, a bar graph. Everybody likes to make a bar graph for everything, but it's really only used when you're comparing separate but related items. So whereas in a line graph, the data is connected to each other, in a bar graph, the data is separate. So here we're showing separate data. We're looking at each individual month of the year. And the reason why we're lumping them together is because we want to look at the birthdays. So if we counted all the students in the 8th grade and we tallied up who was born when, we plotted it on a graph, we would show this. The data is separate. They're not connected, but they're related in that we want to compare the different months with each other for how many students were born in each month. So a bar graph is used then. Finally, the last most common type of graph, we don't use it very often in science, but maybe, is a pie chart or a circle graph. Pie charts are used for showing parts of a whole. So if you think about the whole pie as being the whole, 100%, each piece of the pie is going to show you a percentage. So here's pie preferences. If we pulled the student body and looked at what your favorite pie is, we could break the pie chart up, and 23% of students have cherry as their favorite pie, 30% is pumpkin. Okay, so here is some really important information about when you're making your graphs. What I would like you to do is sketch out a little graph. You can just sketch this one here and make sure you label it here with the important rules and important characteristics of a good graph. So here I have a line graph, and I know part of it is off the chart, so I'm going to scroll up here. What I have here is a temperature in degrees Fahrenheit over a series of days. So I'm watching the pattern, so it's a line graph as the temperature changed over a series of days. Now, some of the things you want to make sure you always include in your graphs always have a title. We want to know what we're looking at here. You also want to make sure you label both the axes. Now, I'm not saying that you need to tell me that this is the y-axis and this is the x-axis. I know that. What I want is what data are you representing on the y-axis and which data are you representing here. Also, make sure if you put temperature or degrees, what units are you showing them in? So if I just put temperature or degrees here, I wouldn't know if this is temperatures in Fahrenheit or Celsius, which would make a huge difference because 53 degrees Celsius is hot. So make sure you include units here. One of the hardest things about making a graph is making sure your labels or your units here are evenly spaced. And not just evenly spaced on the paper, that they're equidistant apart, but that these increments are the same distance. So here we've got a distance of 20. 40 to 60 is 20, 60 to 80 is 20, 20 to 40 is 20. It's exactly the same. Here it's 1, 2, 3, each one goes up by 1. It's very, very, very important that these are equal on your y-axis. You wouldn't just plot these numbers here. It makes a huge difference in that final picture of your data. On this page, I show a bar graph. Again, you're going to include the same things. You're going to include a title. You're going to include axis labels. Here I have types of fruit. Here I have kilograms sold. So again, using units there. What I've included on this graph is how do I know which variable to put on which axis? Does the fruit go here or here? Does the kilograms go here or here? It's really sometimes challenging to do. Very important to remember that always on the y-axis is going to be your dependent variable. This is the data you're collecting. This is the stuff that you wrote down. So here what I did was I collected some data on how many kilograms of each type of fruit I collected. So I had categories and I collected looks like maybe just under 30 kilograms of apples. I wrote that down. It's my dependent variable. On the y-axis is going to be your independent variable. This is the one that you didn't change at all, or you didn't do anything to at all. You didn't record it. These are your categories. So these are, another way to think about it is that the amount sold depends on which type of fruit. So oranges had the most, and so on. Finally, I want to take the last bit here, and please do make sure you write these down, that I want to go over some of the things that I find really important when making a graph in my class. So these, whenever you make a graph, which we'll do many times throughout the year, you're always going to follow these rules. One thing is, please always make it on graph paper, not on lined paper. Make a graph. I mean, it's one thing to sketch out a rough draft of something, but always draw your final draft of anything on graph paper. The only exception would be a computer-generated graph, but that's pretty rare that we do computer-generated graphs. The other thing is make your graph big. Make it so we can see it. Use the whole paper. You have a whole piece of paper of graph paper. Why do you just draw it up here in the corner like that? It's a tiny little graph. It's hard to see. You have all this wasted space here. Look at this one. Goodness gracious, we have a huge title. We've got a very tiny, tiny little graph down here. It's very hard to read. Use the paper. Use a ruler. Straight lines, even, nice, neatly drawn bars. Really important. Make sure you label the axis and have a title. And then make sure your increments are equal. Again, that means that when you're setting up your numbers on your axes, that they're evenly spaced apart. So that's that. Good luck in graphing.